right, so what if I told you there was a shortcut for all this stuff you're seeing in front of you? You'd probably be happy about that, right? Well, in lesson 7.6, I'm going to show you the shortcut to find the derivative that does not involve doing all this tedious work. Okay, the purpose of doing the derivative using this limit definition was to help you understand where it comes from and help you practice your algebra skills. But all of this can be shortened into kind of like one step. So that's the goal of today. So a couple things before we do the shortcut. Derivatives can be written in multiple different notations. The one that's most common is f prime of x. That's what you see here. But you could also write it as y prime. dy dx also means derivative. And then d dx of f of x also means derivative. Okay, the rules I'm going to show you are written right here, but I want to walk and show you an example first, and then we can refer back to those. So first question, find the derivative of each constant function. For this, it would be important to remember what a derivative is. Okay, so let's pretend like this is an x and a y axis. It's a terrible looking graph, but whatever. So let's say I have y equals 3, right? Well, y equals 3 would just be a horizontal line. Any constant value, 2 pi to the third, would be the same. It'd just be a horizontal line somewhere. The derivative of a function is just you stating what the slope of that line is. Okay, so if I have a constant function that looks like this, the slope of that line is 0. Because what kind of line is this? This is a horizontal line. So I'm just going to say that the slope is equal to 0. You don't have to do all this as long as you understand that the slope is 0 because it is a horizontal line. So then what about 2 pi to the third? Well, do you see any variables here? No, there's no variables, meaning that this is just a constant function at the y value of 2 pi to the third. It's a constant function, so it looks like this one, which means the derivative of that function is equal to 0. Okay, the shortcut, also known as the power rule. The shortcut for taking a derivative is that we're going to take the exponent, bring the exponent to the front and then subtract 1 from the power, and boom, you have a derivative. Watch what I mean. This would be negative 3x to the first power, right? So I'm going to use the power rule, which says to take the power to the front and multiply. This would be f prime of x, by the way. So 1 times negative 3 would be negative 3. And then subtract 1 from the power, and this would become a 0. And then the derivative of 5 is just like asking the derivative of a constant, and that is 0. Simplify your answer. So negative 3, x to the 0 power is 1. So we can just say this is the same as negative 3 times 1. And I don't really need to write the 0. So my derivative is f prime of x equals negative 3. Let's try that again. This time my variable is t, but it is to the first power. So using the power rule, we're going to multiply by the power. 1 times e would just be e. And then subtract 1 from the exponent, making it a 0. And then simplifying, this would be the same as e times 1, because t to the 0 is equal to 1. Which means that the derivative of s, also known as s prime of t, would just be equal to e. Okay, let's try another one with that power rule. So x to the 5th. Power rule says bring the 5 to the front and subtract 1 from the exponent, and that would make it to the 4th power. So that is done. See how fast that is? Let's try it again. Now this one I'm going to do just the derivative. I'm going to use the power rule and just do it one term at a time. Okay, one term at a time. So bring the 3 to the front and multiply, which would make it 18. subtract 1 from the power, and that makes it x squared. Okay, do that again. Bring the 2 to the front. Now you have 10. And subtract 1 from the power, and you get x to the first. On this one, multiply the front number by 1, so that's still a 3. And then subtract 1 from the power, and you get x to the 0. And then the derivative of 4 is a constant value, therefore its derivative is 0. Clean it up and you are done. So our answer is going to be 18x squared minus 10x plus 3. Okay, last example here. Same thing, power rule, one term at a time. So bring your power to the front and multiply. That makes this negative 32. Subtract 1 from the power and you have negative 32t. Okay, and then your middle term, you're going to do 1 times 96, which is 96. And it would be t to the 0 power, because you subtract 1 from the power. And then the derivative of 85, because that's a constant, the derivative is 0. So we're going to clean it up and call it negative 32t plus 96. Kind of easy, right? If there are fractions, like down here in example E, you're not going to do anything differently. You're just going to still continue by multiplying. You may just want to write out the math that you're doing so that you don't make a silly mistake. So this one would be multiply by 4 and then subtract 1 from the power. Same pattern all the way through. Multiply by the exponent, subtract 1 from the exponent. Okay, we're going to clean this one up and then we will move on. So 4 times 1/4 is just 1. 3 times 2/3 is 2. 2 times 1/2 is 1. And then 3 times x to the 0, that's just negative 3. So we have our derivative here. Okay, a couple of odds and ends things. This is just going to ask you to kind of recall information from earlier in the school year. Like, what is a negative exponent and what is a radical as an exponent? So anytime you see something out of the ordinary, like you see a radical or you see a fractional exponent, you're going to want to start by rewriting those things in exponential form. So square root of x, that's the same as x to the 1/2 power. 2 over x to the 3rd is the same as 2x to the negative 3rd. Write everything in exponential form and then use your power rule to take your derivative. So multiply, subtract 1 from the power, multiply, subtract 1 from the power. 1/2 minus 1 would be negative 1/2. Okay, keep going. Multiply the powers, the power by the outside number, and then subtract. So you would have negative 6x to the negative 4th. And then maybe you can rewrite it now back in radical fraction form. So 15x squared, nothing abnormal about that. Here in the middle, x to the negative 1/2 means that there would be an x to the 1/2 in the denominator, and x to the 1/2 is the same as a square root. And this is 6x to the negative 4th. That means there would be an x to the 4th in the denominator. Okay, let me go down and do C. So for example C, this is something that's very messy because it's a fraction, and we do not want to deal with this. So what we're going to choose to do is we're going to choose to simplify the expression before we take the derivative. So this is not real complicated because there's only one term on the bottom. So you simply need to take each term and divide it by x. So 7x to the 4th divided by x would be 7x to the 3rd. x to the third divided by x would be x squared. And then you're going to continue dividing each term by an x. Everything's cool up to this point, and then you get to the end. And when you get to the end, 8 is not going to divide by x. So what are we going to do? Well, we're going to rewrite it in exponential form so that we can actually take the derivative of it. That's our next task. So let's write it as 8x to the negative first power. Now we can use power rule to help us take the derivative. So this would be 21x squared plus 2x to the first minus 5. The derivative of 3 would be 0, so that term would go away. And then this would end up being negative 8x to the negative second power. Fully simplified, this problem is going to have everything at the beginning will remain the same, but at the end it would be 8 over x squared. Okay, last one of your challenge problems that you will see would be something where you have to actually multiply before you can do your derivative. So the power rule is very helpful because it's such a convenience, but it only works when you can deal with one term at a time. So if you have a fraction like the one that we just looked at, or you have multiplication, you're going to have to actually multiply all this stuff out before you can do your power rule. So let's multiply and expand all this out first. And then we can reduce that down, and then we should be able to take a derivative. So now there's my simplified function. The derivative of that would then be 6x plus 7.